In part A, we determine the cross product of the two vectors v and w. That is, we find the v cross w. So, according to the cross product rule, we can find the cross product by finding the determinant represented as like this. That is, we put the unit vectors in the first row, I vector, j vector, and k cap. And in the second row, we put the vector components of v vector, which is 0, 2, negative 3. And in the third row, we put the vector components of W vector, which is 2, 6, and 7. And so we have to evaluate this determinant. This can be evaluated by expanding along the first row. And so when we do that, we put this first unit vector I vector and then multiply it with the 2 by 2 determinant, leaving the row and column represented by the I vector. That is, here it will be 2, negative 3, and 6, 7. We then put a negative j vector, and then we leave the row and the column represented by this j cap. And so we will get 0, negative 3, and then 2, 7. And then we put the k unit vector, leave the row and the column represented by k. So we get the 2 by 2 determinant, that is 0, 2, and 2, 6. Let's simplify this. And so this equals I vector times, we write this product, 2 times 7 is 14, minus the product of the other diagonal, that is 6 times negative 3 is negative 18. We then put this j unit vector and then evaluate this 2 by 2 determinant, that is the product of this diagonal is 0 times 7 is 0, minus 2 times negative 3 is negative 6. We then put k unit vector times 0 times 6 is 0, minus 2 times 2 is 4. So let's simplify this. So this equals I unit vector times, this will be 14 plus 18, which is 32, minus j unit vector times, this will be 0 plus 6 will be 6, plus k times of 0 minus 4 is minus 4. So this equals 32i minus 6j minus 4k. This can be written in component form as 32 minus 6 and minus 4. And so this is the cross product of the two vectors v cross w. In part B, we determine w cross v. And so according to the cross product rule, we can write this as negative of changing the order, that is v cross w. And we put this v cross w as we have already found in part A. So therefore this equals negative of the v cross w, which is 32, negative 6, and negative 4. And so this equals, we multiply this negative with all the components inside the bracket. So it will be negative 32, positive 6, and positive 4. And so this is w cross v. In part C, we find u plus v cross w. So therefore, we write down this as, let's substitute the values of u, v, and w vector. So that is 3, 2, negative 1. This is u vector, plus we have to add this with v vector, which is 0, 2, negative 3. And the result of this has to be cross product with w vector. You can replace this w vector, which is 2, 6, 7, 2, 6, and 7. First, let's add the u plus v, that is u and v vector. So we have to add the corresponding components. 3 plus 0 is 3, and then 2 plus 2 is 4, then negative 1, negative 3 is negative 4. And so this is u plus v vector. This has to be cross product with the w vector, which is 2, 6, and 7. So we can find this cross product using the determinants. So I'm going to put in the first row the unit vectors, that is I vector, j vector, and then k vector. The second row I put the first vector components, that is 3, 4, negative 4. In the second row I put the second vector, that is 2, 6, 7, 2, 6, 7. And so let's evaluate this 3 by 3 determinant. Expanding along the first row, we can write down this I vector. This is a unit vector. This has to be multiplied with the 2 by 2 determinant, leaving the row and column represented by the I vector, which is 4, negative 4, and then 6, 7. Then we put j unit vector, and then we multiply with the 2 by 2 determinant, leaving the row and column represented by j vector. And so this gives 3, negative 4, and 2, 7. And then we put k vector multiplied with the 2 by 2 determinant, leaving the row and column represented by k vector, which gives 3, 4, and 2, 6. So let's evaluate this, and this equals I unit vector. We multiply the diagonals, which is 4, 7 is 28, minus 6 times negative 4 is negative 24, minus j vector times 3 times 7 is 21, minus 2 times negative 4 is negative 8, plus k vector 3 times 6 is 18, minus 2 times 4 is 8. Let's simplify this. So this gives, this is 28 plus 24 equals 52, minus j vector 21, this is plus 8, which is 29, plus k vector 18 minus 8 is 10. And so this is equal to 52i minus 29j plus 10k unit vector. This can be written in component form as 52 minus 29, 10. And so this is u plus v cross w vector. In part D, we find u dot v cross w. And so this equals, replace u by the vector, that is 3, 2, negative 1. And this has to be dot with v cross w. We already found v cross w from part A, which is 32, negative 6, negative 4. So here we have the dot product of these two vectors. Remember, in dot product, we have to multiply the corresponding components and also sum with the other products of the corresponding components. So we will have 3 times of 32. We then put plus, then multiply the uh, other component, that is 2 times negative 6, plus this is the k component, which is negative 1, multiplied with negative 4. And so this equals 32 times 3 is 96. 2 times negative 6 is negative 12. Negative 1 times negative 4 is positive 4. And so this equals 96 plus 4 is 100. 100 minus 12 is 88. And so the result of this u dot v cross w equals 88. In part E, we find v cross v, and this equals 0. This is according to the cross product rule. That is, if we cross product a vector with itself, this equals 0. So therefore, here we cross product v vector with itself, so it is 0.